In terms of sinusoids, let us compare another aspect of continuous time and discrete time sinusoids and see where they are similar and different. Suppose I have x of t to be cos omega naught t, and then I have y of t which is cos omega naught t plus theta. So this is a sinusoid that is a phase shift of the previous case. If you want to express y of t in terms of x of t, what would be the relationship? This is nothing but x of t plus theta by omega naught, right? Wherever t is there, if you replace t by t plus theta by omega naught, you will get this. So what is the implication of this? Y of t is a time shift of x of t. All right. Now let us see how this compares in the discrete time case. Now let us consider this particular example. So let us consider x of n as cos n pi by 5, and then y of n is cos n pi by 5 minus pi by 2. All right. Now what I am going to do is, let me plot this in MATLAB. So I am taking 20 samples here, and then x is cos n pi by 5, y is cos n pi by 5 minus pi by 2. All right. Now let me plot both these sequences. So this is the first plot. I'll later zoom this so that you can see similarities and differences. So this is, the top plot is x of n, which is cos n pi by 5. The bottom plot is cos n pi by 5 minus pi by 2. Now let me zoom this up. In the bottom curve, you see the sequence takes on the value 0 at certain indices. In the top curve, there is no sample that takes on the value 0. The other difference that you see is, here it hits the value plus 1, and here it hits the value minus 1. Whereas here, the peak does not quite hit plus 1 and the negative peak does not quite hit minus 1. Correct? So these two don't appear as if they are a shifted version of each other. Correct? Okay, so this, let us go back and look at this. So from the plot, they don't appear to be shifted versions of each other. Whereas in the continuous time case, very clearly we saw that phase shift equals time shift. Now let us take x of n and then contemplate this x of n minus 2.5, whatever that means. Right? So that's why I put that within quotes. So if I take cos n pi by 5 and then replace n by n minus 2.5, I get n minus 2.5 this, correct? And so this is nothing but cos n pi by 5 minus pi by 2. Therefore, it looks as if the sequence y of n is a shifted version, except that the shift is not an integer shift. It is a shift by 2.5 samples. Right now, we don't know how to interpret what a shift by 2.5 samples is, right? Because we are used to things being defined on a set of integers. So when you delay or advance a signal, you can shift to the left or to the right by integer number of samples. So what does it mean at all to shift by an integer plus fraction? So we'll make this notion precise later. We'll come back to this notion later when we introduce the concept of fractional delay. But as far as equations are concerned, you can get one from the other by replacing n by n minus 2.5. So this is as far as basic signals are concerned. So most of it must have been review, and hopefully you learned some things that you may not have encountered in your earlier course. Even though you may have seen discrete time sequences, some of the points that were made here, we hope were things that you had not thought of before.